In this video, now that we understand logarithms, let's go ahead and look at logarithmic functions and their domains. Okay, so a log function, what is that? So let's just introduce ourselves to log functions. Evaluate each, approximate as necessary. Because we know not all logarithms have nice outputs. So let's say f of x equals log base 2 of x minus 1. Then actually that won't be the number, that'll be our function. And so number 1, let's say we want to evaluate f of 3. Well, f of 3 would mean plug 3 in for x, which would give us log base 2 of 3 minus 1. Notice the use of parentheses here around the argument. They are necessary here because of this minus. We need to incorporate all of that into our argument, so we do that with parentheses. If you're ever unsure, use parentheses to encapsulate your argument. And so now I know to do 3 minus 1, which is 2. And then I'm trying to decide, okay, my base is 2. What exponent do I need on that to get the argument of 2? And the answer, of course, is 1. So f of 3 equals 1. Let's look at f of, 17. F of 17 would be log base 2 of 17 minus 1, which is log base 2 of 16. And I have to raise 2 to the 4th power to get 16, so the exponent we're looking for is 4. Let's look at f of 16. F of 16 is, well, you plug 16 in for x and you get log base 2 of 15. Well, no nice exponent on a 2 will give us a 15, so this is more of a calculator problem. The answer should be less than 4, because log base 2 of 16 is 4 exactly, and 15 is a little bit less than 16. And we expect it to be 3 point something. So I'm going to use my calculator here to decide that. And if I don't have a calculator that can calculate this directly, then I'll use the change of base formula and do the natural log of 15 over the natural log of 2. And this guy I'm going to have to approximate, so I'll approximate it to the nearest thousandth, and I get 3.907, which seems reasonable. It's a little bit less than 4. Okay, so let's keep going with this. Let's squeeze one more in on this slide. Example 4. Let's look at f of 1. F of 1 would be log base 2 of 0, because 1 minus 1 is 0. And we have to be really careful here. We're trying to figure out what power do we need on a 2 to get 0. And I want you to understand that if you raise 2 to any power, if you're taking notes, this might be good to write down. If you take 2 to any power, or any positive number to any power, you will get a positive number. So it's impossible to plug in an exponent here on a 2 and get anything other than a positive number. I can't get a 0. So this value does not exist. The function doesn't have an output here. And that's why we're going to talk about domain of log functions, because we have to be careful. We have to be careful with what we input. And remember, domain is input to a function. Okay? So let's kind of summarize what we see here. If you have a positive base, you're never going to get 0 or a negative argument. You'll only get a positive argument. Okay, so that's going to be the key to finding domain of a log. The argument must be positive. Can't be negative, and it can't be 0. Now I'd love for you to get your calculator out and try to calculate this using the change of base formula if you need to, and you'll see that you'll get an error. You should try that. If you're ever not sure if a number's in a domain, type it into your calculator and see if you get an error. So let's do some examples where we find the domain. Let's look at that function we had, f of x equals log base 2 of x minus 1. And what I'm going to convince you of here is that we've talked about critical areas before. We have a new critical area, and that's the argument. Okay? So when we look for domain, we're looking for critical areas. Remember, critical areas are denominators, because you can't divide by 0. Even roots, because if you try to take an even root of a negative, you're not going to get a real number, you're going to get an imaginary number. And now we have this new critical area, which is the argument of a log. Okay, so we have 3 critical areas now. So in this case, my critical area is x minus 1. My critical area is x minus 1. I'll set that equal to 0 to find my critical values. So my critical value for x is x equals 1. So I look at my number line of x values, and I mark where x equals 1. And I have to decide, are numbers to the left of 1 okay to plug in for x in this function? Are numbers to the right of 1 okay to plug in for x? And is 1 okay to plug in for x? We need to investigate those 3 things. Use your calculator if you need to. Let's start with the critical value itself. Let's start with 1. If we plug in 1 here, I'm going to get a log base 2 of 0, which we just saw is impossible. You can't have a 0 argument. So I'm going to write above here log of 0. I know it's log base 2. You can write that if you want. But that means this number can't be in our domain. So I'm going to block it off with an open circle. If I take a number over here less than 1, like 0, right? If I test 0 over here, I get log base 2 of negative 1. So numbers over here are going to give me a log base 2 of a negative number, and that doesn't work either because I have a negative argument. So I'm not going to include those in my domain either. But if I plug in numbers bigger than 1, such as 2, if I plug in 2 for x, I get log base 2 of 1, and 1 is positive. Arguments must be positive. So these numbers work, so I'm going to shade this region. So my domain is everything from 1 to infinity, but not including 1. Okay? So if you want to evaluate this log, you can only plug in numbers bigger than 1. Let's try another one. F of x equals the natural log of 3 minus 2x. And you know what? Let's throw in a plus 5x out here. Domain is x values. If I want to find domain, I need to figure out all my critical areas, denominators, even roots, arguments. And in this case, my critical area is only the argument 3 minus 2x. 5x, even though it has an x in it, there is no critical area. There's nothing to worry about over there. Now I solve this for x, so I subtract 3, and I divide by negative 2. A negative divided by a negative is a positive. And my critical value is x equals 3 halves. So I'll cut my number line at 3 halves. And if you plug 3 halves in for x, you'll see that you get a log of 0, a natural log of 0, which you don't want. So you don't want to include that number. If you plug in a number smaller than 3 halves, such as 0, you get the natural log of 3 minus 0, which is positive. That's good. You get a natural log of a positive. So all these numbers are going to work. But if you plug in a number bigger than 3 halves, I don't know, like 10, 3 minus 20 is a negative number. So over here you get a natural log of a negative. Natural log of a negative, which is bad, so we don't include these numbers. So our domain is negative infinity to 3 halves, not including 3 halves. Let's look at a couple trickier examples and then we'll wrap up this video. Find the domain. Number 3. Let's look at f of x equals, I don't know, the natural log of x squared minus 9 over x plus 2. Well, in this case, I've got two critical areas because I have an argument, x squared minus 9, and I have a denominator, x plus 2. To solve my first equation, there's a couple ways to do it. I'll solve it by factoring x plus 3 times x minus 3, which means that x equals negative 3 or positive 3. So I've got critical values, negative 3 and positive 3. Solving the second equation for x, I get x equals negative 2. So I get 3 critical values. Let's plot them in order on our number line. Negative 3, negative 2, and then positive 3 is over here. If I plug negative 3 in, that's going to give me a 0 in my natural log. So I know I'm going to have a natural log of 0, which is bad. I don't want to include that. If I plug in negative 2, that's going to make my denominator 0. So that's going to cause me to divide by 0, which is also bad. I don't want to include that. And if I plug in positive 3, I already know, because it made this equation true, my argument's going to be 0. So I'll get a natural log of 0 again, so I don't want to include that. Now I've got to look at numbers in between each of these. Now, I don't really have to worry about my denominator anymore because negative 2 is the only problem for the denominator. So I'm really worried about the natural log. I only have to figure out where it's positive. If I plug in a number over here, such as negative 4 for x, and square that, I'm going to get 16 minus 9, which is positive. And that's good. I can take a natural log of a positive. So all of these numbers are in my domain. If I plug in a number between negative 3 and negative 2, like negative 2.5, negative 2.5 squared, I think, is 6 point something minus 9. That's negative. And I'm kind of out of space here. You get a natural log of a negative there, which is bad. We don't want to include those numbers. Pick a number between negative 2 and 3, like 0 for x. 0 squared minus 9 is negative. So I get a natural log of a negative there. That's bad. I'll exclude all those numbers. And then I'll plug a number in bigger than 3, such as positive 4 for x. And that gives me 16 minus 9, which is positive again. And that's good. So I'm going to shade all of those. So the only thing that's shaded is negative infinity to negative 3 union 3 to infinity. And that's my domain. Okay, so I hope this helps you understand logarithm function domains. It's just another critical area. We can tack it on to the list of the ones we already know, cut your number line at the critical values, and just evaluate your function at x values throughout the regions you've created on your number line.